Here's graphing in intercept form that we've been practicing in class. So we know it's an intercept form because we have two factors here with x in it, and they right away tell us what the x-intercepts are going to be, or the zeros. So what I'm going to do is take our function, and I'm going to set the f of x equal to 0. And then my goal is to use the two factors here that have x's in them and use those to set equal to 0, each one of them. When I go ahead and solve, so I subtract 2, so x is equal to -2 and x is equal to -8. So if I put those two actual coordinate points, we have -2, 0 and -8, 0. Those are my two x-intercepts, or my two zeros. And what I can do is set up a quick sketch here. 1, 2, 3, 4, 5, 6, 7, 8. So -2 and -8. So we haven't really looked at many that are all on one side of the y-axis. Yeah, so we're going to look at those now. All right, so if we take the vertex, our vertex is going to be an x-coordinate and a y-coordinate. So to find this x-coordinate that we call h, we're going to take the two zeros and add them together and divide by 2. That's going to give us the midpoint. And again, we can visually see where the axis of symmetry is going to be, where the x-coordinate is going to be located, but we want to know the process just in case the numbers we get are not integers like this. So we go ahead, we have -10 over 2, -5. So this -5, that's the x-coordinate of the vertex. So we can put -5 in here. And then now that we know that -5, let's see, 3, 4, 5, there's our axis of symmetry. We know it's going to be at -5, but we don't know where to put the other dot. So we have to use that number. We use -5, and we plug that into the original function. So the -3 is still going to be there. We don't use that -3 for our zeros, but we use it for all the other calculations that we have. So we have -3 times -3 times 3. And when I go ahead and do that, I know that f of -5, so when x is -5, my y is going to be at -3 times -3 times 3, 27. So now I know my vertex, that's the y coordinate of the vertex. So that's going to be 27. So -5, and we're going to be up here. Let's see, we'll make this, do a broken graph, up at 27. There we go. So there's my vertex at -5, 27. My axis of symmetry, we can label in, that's going to be x equals -5. My axis of symmetry is the same as the x-coordinate of my vertex. All right, now moving along and finding the y-intercept. So for the y-intercept, we want to use 0 for the x. So I take my original function, f of x, but I'm putting f of 0 in. So everything's still there. 0 plus 2, 0 plus 8. And here's where people start to distribute and do other weird things. We're following the order of operations, so we need to do the parentheses first. So -3 times 2 times 8. So we have -3 times 16, and that's going to be -48. So f of 0 equals -48. So that actually makes my y-intercept 0, -48. And let's see, let's do a graph break and say that's -48. So there's my y-intercept. And then now we're looking for a fifth point. So here's all of our information we're looking for. So now we're doing the fifth point. And to do that, I am going to look at the symmetric point to the y-intercept. So if I'm down here at the y-intercept at -48, in order to get back to the axis of symmetry, 1, 2, 3, 4, 5. So I'm going to be 1, 2, 3, 4, 5 over. So these points are 5 away from the axis of symmetry. So it looks like that I'm going to be back at -10 and then down at -48. So we're going to be at -10, -48. And now we can sketch the graph in. And it's definitely not 100% in the shape it's supposed to be, because I have quite a cut in some of my graphs here, just for lack of space. But if we look here, we have an absolute max or min. Which one do I have? In this case, we have an absolute maximum, and the absolute max value is 27. So remember that when you're doing that, this absolute max value is the y value. All right, the next thing we have is the domain, and that's going to be -infinity to infinity. Next thing we have is the range, and the range is going to be -infinity up to 27. Don't put the -infinity second. -infinity always comes first. The interval of increase and decrease, those are x values. These are x values. So we want to walk along our graph from left to right. So when I'm walking along left to right, I'm increasing. And I'm increasing from the farthest x I can go, and that's -infinity. And I'm increasing until x is -5. When I get to x being -5, my axis of symmetry point, the graph goes from being increasing to now being decreasing. So now I'm decreasing from -5 to infinity. And the last thing we have is the end behavior. As x approaches infinity, as x approaches -infinity, those are the only two options. X is either going to infinity or x is going to -infinity. As x goes to infinity, y approaches -infinity. As x approaches -infinity, y goes to -infinity. And that sums up, I think, everything we know about intercept form of quadratics.